Good morning, everyone. Myself, Monica Nansapriya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling the subject code W3017 Embedded C Programming in the Regulation 2021. In this session, we are going to see about the serial communication and the 8051 serial port programming topics. And this slide introduces the topic of serial communication using the 8051 microcontroller. First, we have to explain the main components of the 8051 microcontroller. In 8051 microcontroller, it is the main controller used to process and send data. Then the next one is the MAX 232. It is a voltage converter IC. In this voltage converter IC, the 8051 works with TTL voltage level, that is 0 to 5 volt. But the PC serial port uses RS232 voltage level. So MAX 232 converts the TTL signals to RS232 signals and vice versa. Whereas the RS232 which converts to the TTL signal, whereas 0 to 5 volt, 0 to 5 volt which is converted to the RS232, so that it transfers the signal from one to another. Next one is the RS232. It is the serial communication standard used for the communication between the computer and devices. For the, having the communication, we are sending communication from one point to from between the computer and the devices. We are using the RS232. Then the last one is a PC is used as receiving or transmitting the device. So what is the main concept is the serial communication transfers data one bit at a time between the devices. So 8051 has the inbuilt UART. That is the what is meant by UART. It's the universal asynchronous receiver transmitter for the serial communication. The next one is the two methods of data transfer. One is the parallel communication and the another one is the serial communication. What is meant by parallel communication? In this parallel communication, multiple bits are transferred simultaneously. That is the parallel. Here you are seeing that this is sender, this is the receiver. The multiple bits are transferred simultaneously. Now we are having n number of arrows, no? So we are transferring the data simultaneously and it's using the multiple wires. For example, it's a 8-bit data bus. So we are having the multiple data transfers. And the serial communication is the data is transferred one bit at a time. Here we are using the sender and receiver. We are transmitting one bit at a time. There is a single communication wire is here. So it requires the fewer wires. The main difference is the parallel communication is faster for shorter distance, while the serial communication is more reliable for the longer distance. For the parallel communication, it's a printer cable. So the printer cable, we are using a short distance. It's a highly reliable. And for the serial communication, we are using the USB communication. That is the best example for the serial communication. The next one is the difference of parallel and serial communication. In parallel communication, all bits sent together. In previous slide, we are saw now that means the group of data sent together simultaneously, so that the all bits sent together, and it have a high data transfer speed, and it requires a more wires. We are having the 8-bit, no, so we are having the requires more wires and expensive for the long distance communication, and it's suitable for the shorter distance. Whereas in serial communication, it having the only one bit sent at a time and it have the lower speed compared to the parallel. So it requires a fewer wires and it also low cost and it used for the long distance communication. So what is the idea is the modern systems prefer serial communication because it requires wiring complexity. The next one is the serial communication. This serial communication is how serial data transfer occurs. In transmitting side, the transmitter converts parallel data into serial data using parallel in serial out. That is PISO. That is parallel in serial out shift register. Whereas in receiving side, the receiver converts serial data back into the parallel form using serial in parallel out. That is SIPO shift register. So what is the working process? First, the data enters transmitter in parallel form, converted into serial bits. First, the data is entered into parallel form and that is converted into the serial bit sent through the communication line, and the receiver collect in the receiver end. First, we are discussed about the transmitter line, getting data enters, transmitted in parallel form and converted into serial bits sent to the communication line, whereas in receiver collect bits in the serial form and then it converted into the parallel. So it converted back into the byte form. So serial communication reduces hardware complexity. The next one is the three types of communication system. One is the simplex communication, half duplex, and the other one is the full duplex. First, the simplex is the data can be transmitted only in one direction at a time. The data flows only in one direction, and the receiver cannot send data back. So, what is example for the simplex? It is the television, radio broadcasting. These are the one type. That is, the receiver cannot send data back. The TV, we are watching the TV, but we didn't send any signals, any data to the TV. No, so that this is the example for the simplex communication. Then one is the half duplex communication. This the data flows in both the direction, but only one direction at a time. What is the example is walkie-talkie? Yes, we have to data flows in both direction. We have to speak, but only one direction at a time. In a time, there is a one only one will talk, and then the other will talk. The next one is the full duplex. The data can be transferred in both the directions simultaneously. For example, mobile phone, telephone, landline. These are the examples of the full duplex. So full duplex provides the faster communication. The next one is the communication system diagram. This slide visually represents the communication modes. Only transmitter sends signals. In the half duplex, both the devices can transmit and receive, but not simultaneously. In full duplex, both devices can transmit and receive at the same time. This arrow indicates the direction of the data flow. The next one is the synchronous and asynchronous communication. The first one is the synchronous communication. Sender and receiver share a common clock signal. In synchronous communication, the common clock signal is used for the transmitter and receiver. So clock synchronizes the data transfer. How much the clock will synchronize, the data will get transferred, and it has a faster communication and requires the additional clock line also. For example, the application is SPI communication. This is the synchronous communication for the example of the synchronous communication. The next one is the asynchronous communication. There is a no clock signal is needed for the transmission receiving station. The synchronization is achieved using the start and stop bits. So the simpler and widely used and the UART communication is 8051. UART means, yeah, already I told you, no. So the important is the 8051 serial port mainly uses the asynchronous communication. So next one is the synchronous data communication method. For example, in synchronous method, we are having the transfer block of data together. So if we are having a block of data together, it transfers and have the high speed and the complex hardware. In asynchronous method, it transfer one bit at a time and it will have a simpler communication and widely used in the embedded system. The asynchronous communication is suitable for the character transmission. Next one is the format of asynchronous serial data frame. The frame is a group of bits transmitted together. The components of the frame are the start bit, and the start bit indicates the beginning of data transmission and it is always low, that is 0. And next one is a data bit. It contains the actual information. It usually contains 5 to 8 bits. And next one is the parity bit and it used for the error detection. Wherever the error goes, the parity bit will get detect the error, and it is the optional bit. And it having a two types, that is the even parity and the odd parity. So the parity bit contains the two types, and the stop bit, it always indicates the end of the transmission and it's always denoted as the high, that is 1, and can be 1 or 2 bits. So start and stop bits provides the synchronization. Next one is the asynchronous data frame diagram. This diagram shows the structure of asynchronous data transmission. That is the sequence of transmission. That is an ideal condition. It having the start bit. This is the start bit, and this is the data bits. That is the 5 to 8 is the data bits, and the parity bit is the optional. If there is an error indication in the Asynchronous data frame, there is the parity will, the error will get detection and it is a stop bit. So the communication line remains high before transmission. So the receiver detects the start bit and begins reading the incoming bits. So the proper timing is essential for the accurate communication. Next one is the data transfer rate, and it measures the number of bits transmitted per second. The 9600 BPS means the 9600 bits are transmitted every second. The next one is the baud rate, is the number of signals per second. The baud rate and the bit rate are not always equal. So the bit rate is equals to, here is the formula that the bit rate is equals to baud rate into bits per signal. So if one signal carries means 2 bits means, then the baud rate is 200 and the bit rate is 2 into 200, that is the 400 bits per second. So these are the references. Thank you. We will see the next topic in the next video. Thank you.